Welcome all to my next tutorial in biostatistics. In this tutorial, I'll be talking about the relationship between mean, median and mode and skewness of data distribution. In statistics, there is a relationship between mean, median and mode that is empirically based. That is, for a countless data sets, the relationship between mean, median and mode is equal to 3 median minus 2 mean. And this is usually applicable to large data sets. And this is an empirical relationship. Now, a distribution of data in which the values of mean, median and mode coincide, or if mean, median and mode is same, that type of data distribution is called symmetrical distribution. Means mode is equal to mean is equal to median. The three measures of central tendencies will coincide. Let's see an example which is given here, and we'll find the mean, median and mode using this data. First is, we'll find mean. Mean is equal to sigma x divided by n. Here sigma x is the total of all the values divided by n, the total number of observation, that is n is equal to 7, and if you add up the values you will get 56, that is 56 divided by 7, that comes to 8. Now next is median. Median, in the previous tutorials we learned how to compute the median, and since this is an odd number of observations, we find by using the equation n plus 1 by second item. That is n plus 1 by second item. Here is n plus 1 or 7 plus 1 divided by 2, or 7 plus 1 divided by 2 is equal to 8 by 2, that is equal to 4, or fourth item. Fourth item, you have to arrange the data first in the ascending order. This has to be arranged in the ascending order, and the fourth item will be the median, and here the fourth item is again 8. So median is 8. Now next is mode. Mode is the data which is most frequently repeated, and in this data the repeated value is 8. So mode is equal to 8. Here you can see mean, median and mode is same, or it coincides, or it is same, that is 8. And this type of data is known as symmetrical, or this is an example of symmetrical distribution. And here also you can apply the equation, that is mode is equal to 3 median minus 2 mean. 3 median minus 2 mean. By applying the equation also, we will get 3 into 8 minus 2 into 8, that will come to 8 itself. By applying this equation, median is 8, mean is again 8. So 3 into 8 minus 2 into 8 is equal to 8. And here mean, median and mode are same, that is 8. And this is known as a symmetrical distribution. Now, this will not happen always, and this rarely, symmetrical distribution occurs rarely only. And in case of large data sets, this we apply the equation 3 median mode is equal to 3 median minus 2 mean. Now we'll, for example, in a question, if median, and the question which is given here, if mean and median is given, you can find mode by using this equation. Mode is equal to 3 median minus 2 mean. If any of the two values, if mean and mode is given, you can find median using this equation. And this is the empirical relationship between mean, median and mode in large data sets. Now let's see what skewness is. Skewness is a measure of symmetry. Skewness is a measure of symmetry. When the value of mean, median and mode are same, we say that is a symmetrical distribution. If the value of mean, median and mode are not equal, that is known as asymmetrical distribution or skewed distribution. So, test conducted in a class with 3 levels of question: moderate level exam, then easy level exam and difficult level exam. First, let's plot a graph of the marks achieved by the students in a moderate level exam. Moderate level. In a moderate level exam, the marks is out of 100, 30, 40, 50, 60, 70, 80, 90 and 100. And 50 is in this example, 50 is the central value. So this being a moderate level exam, most of the students will be getting an average marks around about 50. So the graph will be almost like this. That is, the graph will be symmetrical on either side of the central value. This is known as a symmetric distribution. So that means the distribution of data is same on either side of the central value. So this is known as symmetric distribution. And in symmetric distribution, this curve has got a shape of a bell. So it is also called bell curve. This looks like a bell. So it is also called bell curve. Now let's see the example of a easy level exam. Easy level exam. In easy level exam, we plot the marks 30, 40, 50, 60, 70, 80, 90 and 100. And 50 is the central value, and this being an easy level exam, most of the students will be getting very good marks. So the graph will be almost like this. In this graph, there is a tapering end, and that's known as the tail. This part of the graph is tapering, and that's known as a tail end of the graph. And in this example, the tail of the graph is towards the left side of the central value, or towards the negative side. This is the negative side and this is the positive side. And the tail, based on the position of the tail, we say whether the graph is positively skewed or negatively skewed. And in this graph, the tail is towards the negative side of the central value. So this type of graph is known as negatively skewed graph, or this type of distribution is negatively skewed, because the distribution of the because the tail is towards the left side or the negative side of the central value. And this is a graph which we got in easy level exam. And now let's see how let's plot a graph for a difficult level exam. Difficult level exam. If we plot a graph 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. And this being a difficult level exam, only very few students score very good marks. Hardly 1 or 2 students will score very good marks, and most of the students will be getting low marks. And 50 is the central value. Here 50 is the central value. And in this graph, the tail of the graph or the tail of the curve is towards the right side of the central value. The tail is towards the right side or towards the positive side of the central value. So this type of graph or this type of distribution is known as positively skewed distribution. Positively skewed. So skewness, negative skewness, positive skewness. That is based on the position of the tail of the curve. Now let's see how median and mode relate in each type of distribution. In case of the bell-shaped curve or symmetric distribution, mean is equal to median is equal to mode. And in case of a positively skewed distribution, mean is greater than median is greater than mode. And in case of a negatively skewed distribution, mean is less than median is less than mode. So to conclude, in normal distribution of data is same on either side of the central value, and in skewed distribution or asymmetric distribution, the distribution of data will not be same on either side of the central value. And based on that, we say positively skewed distribution and negatively skewed distribution. Thank you.